Okay, this is section 7.1, proportions. As you can see there, I have a picture of, I don't know, hippopotamus, a baby hippopotamus, on a blade of grass. Seems a little out of proportion to me, maybe not to you. All right, starting with ratios. A ratio is a comparison of two numbers. So there's no labels. So when you hear like, my vehicle gets 30 miles to the gallon, that's comparing your miles to your gallon. That's actually what's called a rate. Or you can say, my car can get up to 55 miles per hour if people are pushing. Then you would say that's a rate because you have your labels involved. But a ratio is just a comparison of numbers. So if you are going to compare two different things, like an inch to to feet, you would have to convert either the feet to inches or the inches to feet, and then break down your number so that you can get rid of the label, basically. All right, with that said, let's go ahead. We can write ratios in three different ways. We can write with the colon, so let's just say 3 to 4. We would say 3 to 4. A to B, you can write out the word 3 to 4. And then there's like that fraction bar, that slash, and we would just write 3 to 4. Okay? We're also going to talk in this little section about, excuse me, extended ratios, A to B to C, and you can have 3, 4, 5, 6, 7 comparisons there. And they have here F to G to H to I. They have 4 in that. We pretty much are just going to go with the 3 and the 4 for our extended ratios. Okay, example 1, school. The total number of students who participate in sports programs at Central High School is 520. The total number of students in the school is 1,850. Find the athlete to student ratio to the nearest 10. So this means I have to take all my athletes and compare that to the total number of students. Well, nice enough, this problem gives me the total amount of athletes, 520. It also gives me the total number of students, 1,850. Okay, now there's a ratio. We got a comparison of two numbers. I don't have my labels. It looks pretty nice. However, generally, in my class, forever and ever, you will reduce anything that comes your way. So I'm going to reduce it, but I can't help but notice up here, ooh, they want me to find something to the nearest tenth, which I think is a little odd because a ratio is a comparison of two numbers. But we're going to do what the instructions say. So we are going to take 52 and divide it by 185, and we get 0.28, okay? And you're like, yeah, da, 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 da. It says to the nearest tenth, so we're going to cross that out and actually make it 0.3. And that should be your answer. So kind of watch your instructions. Make sure you know what they want. Do they want that ratio in simplest form? Do they want a decimal? Example 2, in a triangle, the ratio of the measures of the three sides is 5 to 12 to 13. And the perimeter is 90 centimeters. Find the measure of the shortest side of the triangle. Oh, there's my extended ratio. 5 to 12 to 13. And I think I might show you a short little video that kind of gives you a picture of how we can compare 5 to 12 to 13. But for now, we're just going to say it's 5 parts, 12 parts, and 13 parts. I don't know what a part is, so we can call it x. So I got 5x, 12x, and 13x. And I'm actually going to add that all together because I'm looking for a perimeter. So I'm going to say 5x plus 12x plus 13x gives me a total of 90 centimeters. So now if I add them up, 5 and 12 is 17, 17 and 13 is 30. And I solve, I get that part. That x value is 3. The question is find the measure of the shortest side. So my shortest side is 5 times that unit. So 5 times 3 is 15. I'm going to substitute in. Oh yeah, 15. Let's see, 15. Oh yeah, I do need a label here. I am talking about centimeters up here, so it must be 15 centimeters for that side. And just for fun, because you know math is fun, you're going to take, if you need to find the other two sides, 12 times 3 is 36. You can take 13 times 3, which is 39. And if you added these all together, oh my gosh, what would you get? 90. Right? Yeah, if you want to check that out, that'd be great. And that's how you can check your work on a quiz or a test. Example number 3. In a triangle, the ratio of the measures of the three sides is 3 to 4 to 5, and the perimeter is 42 feet. Find the measure of the longest side of the triangle. So I basically have my parts 3x, 4x, and 5x. Once again, we're talking about a triangle, no surprise here. All three sides of the perimeter has to add up to 42. So now I have 12x equals 42. So now I divide both sides by 12 to figure out what x is. Let's see, 36 and a half, 3 gives me 36, and that leaves me 6 left over. So 3.5, and this would have to be feet. Find the measure of the longest side of the triangle. So I'm going to put 3.5 in for x and then take it times 5. So I'm going to have 15 and then another 1.5, so this should be 16.5 feet. Is that correct? I better do a double check. Whoops, wrong button. Let's see if Mrs. Talley did that mathematically correct. If I'm checking, it makes me nervous, like I'm not doing that right. Ooh, it's 17.5. Let me try that again. 17.5. Sorry about that. All right, moving on. A proportion. A proportion is two equal ratios, or sometimes I say two equal fractions. To solve a proportion, we cross multiply over the equal sign. I don't know if they teach it anymore, but sometimes in the middle school, because you do much easier proportion problems, your teacher might say bat and a ball. However, the bat and the ball doesn't work now when you get to geometry. It only works with certain ones. So, we're going to teach you the correct way and the way I want you to go about solving a proportion. We are going to cross multiply over your equal sign. So here's your equal sign. You cross multiply, cross multiply. So you're going to have 6y equals whatever 18.2 times 9 is, and I'm calculating that to be 163.8. Divide by 6. Divide both sides by 6 to solve. And 163.8 divided by 6, I'm getting 27.3. All right, we don't have any label with that. That's just our answer. And what you could do to check your work is you could take 6 divided by 18.2, and I'm getting 0.329, so I'll put 0.33, and then take 9 divided by 27.3. Oh my gosh, I'm getting 0.329, so it's 0.33, so it does work out. So you can always check your answers on those types of problems. All right, next one. This is where the bat and ball doesn't work. If I want to take 3 times negative 26, fine. I'm going to be okay with that. But I have to take 6 times this entire numerator, times that group. So 6 times 4x minus 5. And then you're going to take 3 times 26. Okay, now I take 6 times everything in the parentheses. So I have 24x minus 30 equals negative 78. And then I'm going to add 30 to both sides. So I've got negative 48. Divide both sides by 24. I get negative 2. All right, and what have I done? I've solved for x. And once again, you can go ahead and check to make sure that's going to work. Is negative 13 over 3, if I put negative 2 in there, I get negative 13 over 3 is the same as negative 26 over 6. Moving on to example 6. You know what? I think I'm going to have you work through example 6 on your own and bring it to class along with all your other examples that you're copying. Make sure you can do that one right. Lovely, lovely. Moving on, example 7. Oh yeah, story problem. A boxcar on a train has a length of 40 feet and a width of 9 feet. A scale model is made with a length of 16 inches. Find the width of the model. Okay, so we're saying we have a length of 40 feet and we have a width. So I'm going to do the length of 40 feet and a width of 9 feet. So this is all in feet. Scale model is made with a length of 16 inches. What's the width going to be? We don't know. Now, there's other ways to set this up. And I don't know if I should show you every single one. But you can set it up like this because you're saying length to width on the boxcar is the same as it is on the model, the length to the width. Okay, you could also do this. You could say 40 is to 16 as 9 is to x. And you can do that because you're saying boxcar length to the model length is the same as the boxcar width to the model width. You can turn this one upside down, so you can have 16 over 40 is equal to x over 9. And you can even turn this one upside down. You would have 9 over 40 is equal to x over 16. And you're like, why would I do all of that? I would just write it down the way I want. All right, here's the deal. No matter how you do any of these problems, if you cross multiply, let me do my example first. I have 40x equals 144. If I cross multiply here, 40x equals 144. Cross multiply here, 40x equals 144, and you guessed it, 40x equals 144. So I've done it. No matter how I set it up, it's going to give me 40x equals 144. All right, so then I got to solve. So I have to just divide both sides by 40. I'm going to calculate 144 divided by 40 equals 3.6. And that represents x, and x represents the width of the model. And that's what they want us to find. And I should have a label for this. The boxcar was feet to feet. The model was inches, so this is also in inches. Because the units are same in this ratio, the units are same in this ratio there. All right, moving along. Example 8. 2 large cylindrical containers are in proportion. What does that mean, a cylindrical container? That's like this. Oatmeal usually comes in, big thing of oatmeal. Cans of soup, okay? The height of the larger container is 25 meters with a diameter of 8. So I'm going to put 25 to 8. What am I comparing? Height to diameter. So what do I have to do in the other proportion? I'm going to have to compare my height to my diameter. The height of the smaller container is 7 meters, and find the diameter of the smaller one. So I'm going to put an x. Okay, so I'm doing the larger to smaller. And I cross multiply. 25x is equal to 56. And then, of course, I go ahead and do my math with that. 56 divided by 25 gives me 2.24. And it doesn't say what I need to round to, nothing like that. I'll just leave it as 2.24, and that would be the diameter of a smaller container, and we are talking about meters. Okay. And that ends our lesson over 7.1. Talking about proportions, I think that picture looks a little out of proportion as well.